projectile. We have seen earlier that if on the ground a body was thrown vertically upwards, then it just goes up like this and then comes down by the same path. This is a one-dimensional motion, and we can express it with the help of only one coordinate. So the origin, the point of throw, and this is the y-axis. This is the initial velocity, that was u. Now compared to that, suppose I consider ground like this, and a particle was thrown at an angle like this. It's not thrown vertically, it's at an angle we are throwing it. So what would be the motion of the body? You can say intuitively that the body would be traveling in a path that is curved and that is spreading over a plane, something like this, right? Now, in such a case, the first thing you note is that the angle that the initial velocity u is making at the horizontal, that angle is an acute angle, that is less than 90 degrees. If you compare the case of one-dimensional vertical throw, there of course alpha was 90 degrees measured with the horizontal. So first thing we must say is that if we could draw a coordinate system, and if we take this point as my origin, the point of projection, then you require two axes unlike one axis. An x-axis describing horizontal motion and an y-axis describing vertical motion. So such a particle that I described just now, that is given by this red dot and that is moving in a curved path in 2 dimensions and eventually landing on the ground, once again this red dot, such a particle is known as a projectile. So projectiles are those particles which are thrown obliquely from the ground, as I have shown. And the path it follows, the path of the projectile, is called trajectory. There is a special name for that. This is called a trajectory. This is of course a curve, as you can see. We shall prove later. This type of trajectory is called a parabola. This is part of a parabola. Here y is varying as a quadratic function of x. That we shall see later. So once again quickly what I have just now said, if we compare the one